Okay, so we're going to analyze right triangles a little bit, and there's a reason for that. Right triangles are very, very, very important triangles for a lot of reasons. I hope we kind of express some of that to you right now. Okay, so I just made a sector there, and what I'm going to do is I'm going to make a little right triangle machine. And so what I'm going to do is I'm going to just make a parallel line, and I'm going to place a point on that parallel line, not point C, because point C changes up and down. D is stuck to the line now, and if I don't move C, D will not go up or down and just stay on that parallel line, parallel to AB. I'm going to make a segment between A and D. So now I have a side here of a right triangle, and this side I'm going to have be my hypotenuse. So that means this is going to be a leg here of my right triangle, and I need another leg of the right triangle. And I'm not going to bring it down from D, because I need it to be a right triangle, which means it needs to come perpendicular from this leg. I need to have a right angle right here if this is going to be my hypotenuse. So let me construct a perpendicular line that goes through that segment and comes to B. And we'll place a point where they intersect. So let's just find that intersection point right here. Okay. And now I can just form this triangle, which is, you know, triangle A, E, B, and then I have a right triangle. If I get rid of these lines, you can kind of see it a little better. I'll get rid of that segment there. We don't need that. So they're not going away, but they're just hiding a little bit. Okay? And the point of D being on that line was that I could come over here and adjust D, and as such, adjust the right triangle. Okay, so I want you to notice something that I'm going to show you that happens with D. Okay, and that is I'm going to put a tracer on point E. I want you to think about how many right triangles we can actually form here. So that means we're going to trace point E, and point D I'm going to animate. We'll take point D so we can't see it there. We don't need to see it anymore. So I want you to look at this. We're seeing the right triangles, and wherever there's a possible right triangle with that segment, okay, the diameter is staying the same. It's a fixed diameter. And you can see that there's only so many possible right triangles that are formed, right? These are all the different angles by which we can form a right triangle. I'm going to show you something else about that. There's actually, you might say, okay, there's this many right triangles that can be formed. The reality is, there's only half of that. And there's a reason for that. Let's find our midpoint of this hypotenuse here. There's our midpoint. And what I'm going to do is I'm going to reflect, and I will, let me get that side D. Let me get that animation off there. I'm going to reflect my triangle about that point, that midpoint. So I want you to see. Oh, let's try that again. Escape. Here we go. We're going to reflect the polygon across the point. So what I want you to notice here is that, you know, this triangle that exists is the same exact triangle as this triangle here. It's just looking at it from one angle or another. This is from angle A looking at it. This is from angle B looking at it. You know, so this one here underneath is just as though we're looking at it from B. So if I animate again, let's see, D, I mean the total number of triangles really are half of them, because by the time I get halfway, you know, this is a semicircle, right? So halfway up the semicircle to here, that's the most right triangles I'm going to get, because then after that I start repeating the triangle. I start making another triangle, right? Okay, I'll take that other triangle off. It's kind of confusing a little bit. So that's important to think about, though, that there's only so many right triangles. Okay, there's just so many of them. I'm going to take these points off because we don't need them. There's only so many right triangles, limited into how many right triangles there are. That's kind of an important concept. And it's even more important when we consider similarity. When we think about similarity. Now, these are all the right triangles that I can make with the diameter of this size. So what would happen if I changed the diameter? Well, let's turn that let's turn that animation off. Let me take point E and turn the trace off for a minute. Let's change my diameter. So I can grab, oops, I can't do it with that. I'm going to grab this point here. Let me take off the markings because that's getting hard to see. Okay, that's point B I'm going to grab here. And I'm going to redefine that diameter. Okay? And all I'll find when I animate again is another set of right triangles again. So it'll come up and it'll represent, and I need to mark it here. Let's get that thing tracing again. And you'll see that we have another set of right triangles. Oh, and actually, that didn't come out very good, did it? Because I think I maybe shouldn't have moved my point so far up. In any event, we only have so many right triangles that can be formed. Let's see point C, and let's move our parallel line out a little more, and then we'll be able to see more of these. There they are again. Okay, so there's all of the possible right triangles. Again, very limited. There's only so many. You know, really what fits in a quarter of a circle is all there is in terms of right triangles that there are. And here's when we talked about similarity. Okay, let's do it. Let's take our right triangle. I'm going to pause that animation again. And let's say this is all the right triangles that exist for that diameter. But remember something really, really important. With dilations, right? We can dilate from some point that exists. And let's say we dilated with a factor of 1.5. Well, what do I end up with? I end up with a similar triangle. So in essence, I have this right triangle. Let's animate again. Here we go. We're going to get tired of this animation stuff. But you can see that I'm actually constructing any right triangle within that circle. Is any right triangle could be created with any diameter is going to be similar. So when I talk about how limited this is, there's only this many right triangles in the world. That's it. That's all that can be created. And then, of course, I can dilate, and I have other, sizes, but they're basically the same triangle, just been dilated. So similar triangles. All right triangles are similar. Why else is that important? Well, let's talk about something else here. Ready? This is really important here. Remember that the angle measures are going to be the same. Right? The angle measures, if we're dilating, the angle measures are the same. Let me change this point a little bit. Bring the point in, we get a different set of triangles there, but the scale is going to be the same there, 1.5, right? So the angle measure is going to be the same in all the ratios between those angle measures are going to be the same. So now we're talking about, let me show you one other thing too. May as well show you one other thing. Look at this. Let's say I just had a triangle that was clearly not a right triangle. Well, if I study right triangles, I'm going to figure something out really important. And that is every triangle has two right triangles in it, right? Let's look at this. So if I can learn about let's make those two triangles here. There we go. We have triangle H, K, J, and triangle J, I, K. I have those two triangles. So when I was looking at triangle HIJ, I'm really having two separate triangles here, aren't I? Two separate triangles. Let me get those triangles out here. We can look at them. Oh boy. Escape. And undo that. Sorry about that. Here we go. Let's redo the triangle again. Now, I'm going to make a copy of this triangle. Let's try that one more time. Undo, redo. Let's make a rigid copy of these triangles. So I have boom, boom. I might have too much going on here. Well, it's going on. It's getting a little crazy, but I hope you can see this triangle here and this triangle here. So this set of right triangles that we just looked at, that he created, right, that set, that is the total number of triangles that exist that are right triangles, and also make up all possible triangles of any size. Because any triangle I make is made up of two right triangles, right? I can always divide it into two right triangles. So this is why learning about right triangles is extremely, extremely important, okay? I'm going to kind of zoom out here a little bit, give me a little space. I want you to notice something else here now. We're going to do something a little bit crazy here. So what I'm going to do is I'm going to measure angle A. Let's measure angle A. So I'm going to come over here, I'm going to click, give me the measure of angle A. And that says that as of right now, angle A is a 30-degree angle. I hope you can see that right there. 30-degree angle. And now what we're going to do is I'm going to enter in a spreadsheet, and we're going to record there that angle. So I'm going to keep that angle and record it into my spreadsheet. So always that angle is going to be there. Now we're going to also record these sides here, these side lengths. So we have side AE, which was called segment B. So if I come down here, this is the length. Where is B? Not B prime, but B. Sorry. Oh, that's B1. No. Sorry. Yeah, BE, which is AE, a polygon 1. So B1, so let's find segment B1 right there. We're going to record that one in our spreadsheet as well. And let's get this segment over here, that's A1, and let's record that in our spreadsheet also. So it turns out, now what I'm doing is I'm recording the angle measure and the measure of the two legs of the triangle in here. And now when I animate D, and I go ahead and I'm going to, not D prime, sorry, D, turn the animation on here, you can see what we're doing is we're capturing every angle measure that that this computer is capable of capturing. All these angle measures, okay? Here we go, we're capturing the angle measures here of A, and we're also capturing all of those side lengths, okay? So that's pretty much what we did. Let's turn that off, and I want to now consider this for a minute. Turn that off. Now I want us to come up here and take a look at all these angles, all right? So it starts out here that we have they start out just inside of 90 degrees. Then as it climbed, we had these measures, but the measures disappeared. Let me go back to the beginning. Here we have all of these angle measures starting at 0 and climbing up. There's a 19.38 degree angle. You can see that there is a special, there is a length here and a length there. It turns out that for that degree A, remember, any triangle that's 30 degrees is going to always look the same, any right triangle, if I've dilated it, and the ratios are going to be the same. So if I made a ratio that was, let's say one length that's equal to this length, that's A1, divided by B1. I don't know if that'll work. It did not work. It's equal to, say, B1, or C1 divided by B1. That's not going to work either just yet. Let's try this. Use my function editor here, and I say it's equal to, and let's try that. Now, this is equal to this value here divided by that value there. Let's hit enter. Yeah, there we go. See this ratio? Now this ratio is something we call tangent. This is a ratio we call tangent. And it turns out that that ratio is going to measure exactly the same. We'll get that same exact measure at tangent ratio for any 30-degree right triangle. So we'll get back to that in a minute. We'll talk about some more ratios in just a little bit.